Welcome everybody, and thank you for joining us. My name is Paul Radine. I'll be hosting the webinar this afternoon. I'm with Hawkridge, and this is our very first webinar with our brand new partner AMT. So we're excited to get that going. AMT's really going to open up a lot of new opportunities for our customers in the 3D printing area. You know, not only looking to enhance the aesthetics of their parts, but also the performance as well, and frankly, the overall workflow as it relates to post-processing. So I think you're going to be very impressed with the technology offering that AMT has to offer, and you'll learn a little bit more about it here today. So again, welcome. My name is Paul Radine. I'm the Vice President of Digital Manufacturing here at Hawkridge. I've been involved in the 3D CAD and additive space for a little over 25 years now. So I've been exposed to a lot of different types of technologies and advancements in the additive space, and it's been an extremely exciting industry to be in, to see not only advancements in the technologies, but the advancements on how various companies are using these technologies. What used to be typically, you know, strictly for prototype use, now we're seeing that transition into end-use customer parts. Joining us from AMT today is Luis Folgar. Luis is Chief Technical Officer and has been an active participant in the AMUG groups. For those of you that don't know, that's the Additive Manufacturing Users Groups, which a lot of in this COVID time, they get canceled, and hopefully we'll be back, you know, joining those audiences on a more frequent basis at those types of events. But Luis also holds a range of patents in the areas of materials, design, manufacturing processes, advanced post-processing technologies, and 3D printing. So we appreciate Luis, you joining us here today. We also have Brad Dermott, and Brad's professional experience has been centered around additive manufacturing applications and technologies. So Brad and I have got to know each other a little bit, you know, through this process of developing the AMT relationship. Brad was instrumental in working with myself and other Hawkridge team members as we really went through the process of vetting out AMT, I should say. And that meaning is that when we bring on new technologies within our organization at Hawkridge, we want to make sure that we represent the very best technologies in the industry. So we like to learn, just like you customers do. You like to learn a lot about the organization, the vision, the growth and opportunity of those organizations, and then obviously what the products can do and how reliable they are. So Brad's really helped us out a lot in that area and is a resident expert in these technologies, and we'll be talking about them here today as a product portfolio. So again, welcome Brad and Luis. And for those of you that are attending Hawkridge for a webinar put on by Hawkridge here for the very first time, I just wanted to share with you a little bit about our organization, just a couple minutes here. We were founded in 1996. We provide design, engineering, and digital manufacturing solution services. That's a primary focus of our business. And as you can see here, we have an extensive product portfolio that covers four key categories: design, manage, simulate, and manufacture. So those are the four key areas that companies typically go through as they develop a product and bring up through the product life cycle. And then also one of the other key areas that I was going to mention, or I'm going to mention, is the training services aspect related to to our side of the business. We believe in supporting what we sell. So here at Hawkridge, we work with our customers to assure that they are successful all the way from pre-sales and identifying the best solutions for their specific need, as well as installing it or implementing the total solution and training and supporting them for many years to come. So that, again, that just gives you a little brief overview of our product portfolio. And the final slide I got here is just a little bit of a roadmap or territory map, I should say, of the various offices that we cover across North America. We have roughly around 250 employees. We work with a customer base of over 23,000 companies, and a lot of those, range anywhere from small, very small job shop company organizations, all the way up to Fortune 500, 100 companies as well. In amongst these offices as well is we have 7 different locations that have digital manufacturing labs. Those digital manufacturing labs provide where we provide live demonstrations for various 3D printing equipment and post-processing equipment as well. So as I mentioned, we have Luis and Holgar with us, and I'm going to pass it over to Luis to give everybody a little bit of an idea about who AMT is, because it sounds like there's a lot of people that are a little unfamiliar with it. So I'll hand it over to you, Luis.
Hello, everybody. Just really quick, as I said, thank you so much for the opportunity, and thank you for the interest in our company. Our company, to give you an idea of how we started, our company really realized that 3D printed parts essentially are not ready for use out of the printer. So they're still unfinished when they're done. So to us, this presented a huge opportunity to break down a barrier that essentially continues to prevent many of you to transition to production for additive manufacturing at scale, or just in general, to allowing some of these 3D printed parts to be considered as end-use products. So we're going to touch, as Paul said, in a lot of benefits that our technology is adding, because it's not just about finishing the part, it's not just about reducing cost, but it's also about adding value and adding performance to the part through the technologies that we utilize. So we focus on affordable and sustainable automated post-processing solutions. Our company was founded in 2017, headquartered in Sheffield, United Kingdom. Our CEO, Joseph Crabtree, started the company with our chief engineer. Both, they're alumni from the University of Sheffield, and decided to license technology from the post-processing technology from the University of Sheffield, and built equipment, transition it from the lab to an industrial scale, and make it more accessible, automating it, and putting it in the hands of the people that need it, many of us in the industry. So our company has got 65 employees. We are spread throughout the globe. Us, Brian and I, we are headquartered in Austin, Texas, where we got a 20,000 square foot facility. It's devoted to do research and development, partnering with private industry and government. A lot of the technologies that we have, they are still being explored for other applications, not just for finishing, sealing, cleaning parts, but for many other applications that have to do with surface engineering, and also treatment of parts, whether it is for coloring or for other type of functionalization. So I think you guys feel free to ask any questions, whether it is about our products or about what is in the pipeline. I'm the Chief Technology Officer for the company, so you'll get the benefit to pick my brain, and I'll welcome you to do so. We are backed by a major companies in the industry. DSM, we closed a Series A round of funding last year. Fortunate to partner with them. DSM is very active in the additive space, and with them we have been able to reach new levels of engagement with the end users, with multiple material companies like DSM and other OEMs and other resellers as well. So Foresight Williams, they are the venture capital arm of Williams Engineering Formula One. So they also joined DSM on our Series A. So we're well funded, and this funding has allowed us to expand and go through the global expansion and engage with strategic resellers and experienced resellers like Hawkridge, so that we can put this technology in the hands of users like many of you in the audience. So all our products are designed and manufactured by us. We don't subcontract anything. We have our manufacturing facility in Veszprém in Hungary, where all our technicians, all the engineering, research and development towards product development efforts is going on in the UK and Hungary. And our manufacturing facility does everything from the software, user interfaces, wiring, welding, everything. So we have a lot of control for many of you that may be interested in looking at some custom applications that may not necessarily be out of the box. We have full control on the product development, engineering, manufacturing efforts. So with that, what I'd like to do is just focus on the importance of post-processing, because many of you may be wondering, okay, well, what is this all about? So maybe if we can go to the next slide, what I want to do is highlight that essentially, depending on the application across multiple industries, the impact of post-processing on the ultimate cost of a 3D printed part, it can vary significantly. So, I have been fortunate to be part of this industry since the very beginning, during my freshman year at Virginia Tech. My background is material science, and my experience with 3D printing started just researching materials and trying to understand the weaknesses of why were they being used only for prototyping? Why couldn't we use them as end-use parts, right? And then as the technologies improve and they're mature, I was able to be part of the transition of rapid prototyping to true additive manufacturing. And as an industry started to qualify additive manufacturing for true production and scale it to production, what I've learned is that, one of the most significant barriers to the transition to production is the cost of post-processing. The cost of a 3D printed part can come in from, the preprint, which is the cost of pre-printing, which is, software and the knowledge, know-how to prepare a build or prepare or design a part for 3D printing. But and then you have the print, the material, and the post-processing. But after you try to qualify an application for production and all the stars align on software, on the printer cost, the throughput, the material properties, all the process and all the process settings and conditioning, so that you can have something that is robust and repeatable enough to go into production, you come to find out that there's still economies of scale that don't make sense. And one of the reasons is because post-processing is so expensive. So depending on the industry, whether it is eyewear, footwear, automotive, medical, or aerospace, you can see that there can be a wide swing, or of the cost, just the percentage in terms of cost attributed coming from post-processing, going from simple parts like eyewear, temples, and focals that are 3D printed and fully customized, that are really simple to produce, and you would think that they are extremely easy to finish, but it's quite the opposite. That the smaller and the simpler the part, it's almost the harder it is to, and the more expensive it is to finish it and to post-process it. And then you look at other industries like automotive and aerospace, where the cost can be anywhere from 30% for automotive and 40% for aerospace. So on average, I think it's safe to say that 44% of no matter where you are, 44% of the cost of the ultimate 3D printed part comes from post-processing, which is significant. So that's essentially where we focus. That's where we saw a niche for us to make a huge impact. So if what we are going to present to you today is essentially the range of products and technologies that AMT has been able to offer, and how we went about to introducing them to the market, and why. So I hope that as we move into describing all these products in the next slide, Brad and I will do a job, and feel free to ask any questions coming from any of these industries, consumer, automotive, or any of the other ones. If you have a specific one, I think we've had a lot of experience on looking at many of your applications where there is no an agenda, but we're free to answer any questions. It's Brad. I'm not sure if you want to take it from here and walk us through the product line from AMT.
Yeah, absolutely. Yeah, thank you. And so these are our products that we offer currently. So chemical vapor smoothing, and then also depowdering. But as we approach the post-processing challenge, and we put together our plan of attack, we started with vapor smoothing first. So this is the flagship machine that we started with was the PostPro 3D, the machine on the right, the larger system there. That is our flagship machine that we've had out in the market for several years now. And the reason why we started here was, one, because of what Louis said, that we built this off of a license from the university and brought this into an industrial setting. But we also saw the huge benefits of improving the aesthetics, the sealed surfaces, and improved mechanics, and realizing that when we attack this, we can lower that post-processing cost pretty significantly with this automated solution. And throughout the years of learning this system, we also realized that we have the ability to scale this process up and or down. So that gave us the PostPro 3D Mini, which is the smaller unit to the left, built around the exact same technology of using a chemical vapor to smooth the surface of the parts. And so how these actually work is that what we do is we load your thermoplastic polymer parts printed off of any kind of platform. We load this into the system, and what we do is introduce a chemical vapor onto the surface of your parts, and we ensure condensation and basically create a flow state on the very outside of that surface. And so we're kind of micro melting, if you will, the surface of the part, and creating that flow to then remove the porosity, the layer lines, and that rough feel that you normally get, particularly off of powdered parts. You get that granular sand finish, or FDM parts, you can get the coarse stepping and layer lines just from the technology itself. And so what we do with that flow state is remove all of those blemishes. And then after that flow state, we need to make sure this stops. So we go into a curing step, and then we finish off by drying the part to ensure that all vapor that has been used on and inside the part has been pulled out and removed, and then recondensed into the system, making this a completely closed loop system. So we have the chemistries being used in sealed canisters. We introduce the virgin into that processing chamber, smooth our parts, and then recollect into a used canister, which we then take back to our facility for recyclability and reuse, making this a good sustainable solution as well. So these cycle times, for reference, is about 1.5 hours to 2 hours. And after that full cycle time, these parts are completely finished. It doesn't have to do a secondary process of drying or cleaning or anything like that. They can move on to that next step, whether it's assembly, packing, dyeing, coating, painting, whatever it might be. The parts are ready within that 1.5 to 2 hour window. And so over the course of learning about this system and this process, we came across a very common challenge when it came to vapor smoothing. And that was the surface of the part and the cleanliness of the part before vapor smoothing. So that brought us back to the drawing board, and then we developed our automated depowdering solutions that you see here on the right, the PostPro DP and the PostPro DP Pro. Both of them are built around the same technology as far as how the system depowders and or shot peens the surface for a better improved finish. It uses a combination of a part tumbling basket and two nozzles blasting a type of media, generally glass bead for depowdering, or ceramic or stainless steel bead for shot peening. And that'll be blasting on these parts in the tumbling basket. And then on the back side of each unit, we have a large cyclone. The purpose of this cyclone is to separate your media, your blasting media or shot peening media, from the powder that is removed from the part, or dirt, or whatever might be on the surfaces that are now removed. That is separated out, so you're continuously using the same new media and clean media on your parts, and pulling out all of the used powder and dirt and in a separate container and being disposed of. And the biggest benefit of these systems is not only are we controlling the cleanliness of those parts, so we can now vapor smooth them very efficiently and more effectively, but we're also significantly reducing the labor involved for depowdering. I remember back in my day spending hours in front of those manual blasting cabinets. I'm sure many of you are very aware how much time it can take to manually blast hundreds of parts, where, you know, now with these units, you're able to do large quantities in under 30 minutes. And even it says here 2-in-1, I just want to kind of stress the point that both systems can be used for depowdering or shot peening and surfacing. So we kind of believe that media open source for the consumer and operator to use, because some find very unique ways of resurfacing and different medias that can be used for that.
So Brad, real quick, because that was one of the questions that actually had come in, which was, do you have to buy AMT supplied blast media? So you're saying that you can use just open source, you know, any recommended blast media from any manufacturer, is that correct?
Yeah, that's correct. Assuming it's, you know, new and clean material, and it's dry media, yeah, you could use any range of glass bead sizes. We recommend somewhere between 70 and 110 micron bead size. The higher quality bead, the longer it'll last through cycles. So a bead has a cycle time through the system, and the more it's hitting the impact of a part or anything else in the system, it tends to break up. So the higher quality bead can last longer, but that's why we want to leave it open, so no one's forced to purchase a media that they feel is just too high of a cost at the time.
Mm-hmm.
So that's why we wanted to leave that open.
And Paul, just to add to that, I think what it's important for the audience to understand is that, you know, by us introducing a limited selection of media, I think we're not necessarily adding any value to the end customer, because the reality is that when it comes to the world of blasting media, it's not new technology, right? Like, it's been very well researched and commercialized. So there is a number of options. Some are better than others. We do have the expertise on what is out in the market, and we love to partner and make recommendations and make direct connections with the suppliers that we recommend. Some of the world most renowned experts when it comes to blasting media, so that, you know, you get a quality product that will last longer, which is important to also, you know, for us. Let's be honest, and when you guys think about post-processing, most of you say, okay, well, now any type of post-process, anytime that I have to add something to a 3D printed part, it's an extra step. You know, it's becoming more expensive and it's taking longer. So it becomes slower than it already is, right? So we are in the business of making this affordable and breaking the barriers of transition to production and of additive manufacturing. Otherwise, we're erasing, you know, the benefits of additive manufacturing. So our goal has been to design these technologies and to design our business model so that we are, you know, sustainable and that we are affordable, trying to bring down the cost, which includes, you know, the cost of ownership and the cost of running this equipment.
Mm-hmm. Okay. Hey, one other question. This goes back to the vapor smoothing. So are there multiple chemistries, or how many chemistries do you use for vapor smoothing?
Yeah, currently between both the Mini and the Post Pro 3D, we use one single chemistry we call Blast X. And that chemistry we've used from the start and up through to this day, giving us the ability to process. I believe we're at over 120 compatible materials that we can smooth with that chemistry. And now that, the material engineering, it just continues to grow and become more and more complex, and uh, different materials require a different environment and a different kind of chemistry behavior. So we also continue to research and develop that. And so throughout this year, we're exploring new chemistries to field things like Lubrizol TPU, for example, and now the latest polypropylene. That'll be on our plan throughout this year to really bring that to market and allow us to unlock applications using those material properties as well.
Great, awesome.
Yeah, so these are the products. We can go ahead and dive a little bit deeper into each of these if you wouldn't mind hitting the next slide here. So when it comes to our Post Pro Vapor Smoothing, we kind of separated into three pillars that we like to talk about. So I'd like to start with the fact that we wanted to make sure that this technology is easy to adopt. And what I mean by that is we wanted to make sure that we have a safe and affordable solution to allow users and industries to scale up with this process and allow them to scale up with their production, because now we have reduce that post-processing time. We can now, customers and people can now use this technology to hit higher volumes with better ability on the part. And we also want to make sure that we meet strict health and safety and environment standards to make sure that we can have this technology located anywhere, even the strict states of California over there by you. So we wanted to keep that in mind. And then also, it's a near plug and play type of install. We wanted to make sure that, when a new user brings this technology in as a true solution to automate their post processing, we want to make sure that they're up and running within the same day. So there's various pieces of equipment involved, but it really is a plug and play solution. We do a training within a day, and we have our first run within a few hours to get that system going. So that's another big focus on it. And and the fact that we've been able to process over 120 different materials, this system can now be used across multiple industries and not limiting to a specific one. So that's another ease of adoption focus that we wanted to keep in mind. And the other is production. Sorry?
No, I was just going to chime in real quick, just because, and we'll be getting to a couple of these questions shortly. But one of the individuals here was asking, specifically about, do we support Markforged Onyx, from vapor smoothing? And Sean, who asked that question, we've got some images coming up here shortly to show you on what exactly that looks like from a before and after side of it. So hold tight on that one.
Yeah, but that is a good question. The main reason is so we get that question a lot because it's mixed with chopped carbon fiber, and it's a composite, right? So there's many other materials out there that are like a composite. There can be glass bead, there can be, Markforged has Kevlar in there as well, alumide, something like that. So what we're able to do is, since we're smoothing the thermoplastic, so the binder in most of those materials are like a PA12 or a PA11, that's really where we're spending our focus, is we're, as I mentioned, that flow state. We're putting the plastic into a flow state and allowing us to smooth the plastic, and it actually brings the added components of fibers or what have you along with that flowing material. So we're able to smooth those parts as well. So then another focus is being production ready. We want to make sure that if we're designing a solution for production, that it actually is meeting that standard and meeting the mark. Because we don't want to just have a system that's there, a me too kind of solution. We want to make sure that we're producing the right market leading solution. And so we do that by using a safe and fast acting chemistry to allow for very efficient and properly controlled smoothing. We pride ourselves in the ability to essentially unlock our machine and allow the user to tailor the finish to whatever desire they need, whether that's the right surface finish, the how smooth they want it, and everything like that, allowing us to control that within the system. And then with that, we want to focus on repeatability with high throughput and very low operating costs. Like Luis said, we want to make sure that we keep that post-processing cost as low as possible. And so we did that by creating a large processing chamber, the largest being the Post-Pro 3D. And that allows us to layer and stack hundreds of parts, if possible, into that processing chamber. And now instead of post-processing a single part by hand, whether that's sanding or coating, we can now do that tenfold with hundreds of parts at one time within that 1.5 to 2 hour cycle time. And we also wanted to make sure that as we bring this technology further into the future, we can make it smarter, make it better. And so we want to make sure that we maintain the ability to integrate other automated systems. We have other systems out there utilizing robotics to support the unloading and loading of parts onto processing racks, and also loading and unloading the processing rack, removing even that human element out of this automated solution. And then in the future, being able to tie it into the other post-processing systems that we have, including the depowdering, finding a way to automatically depowder and then bring that out, fixture up your processing rack, and so on and so forth down the line, and really bringing us closer and closer towards that true turnkey solution. Now, the last one here is added value. And what we'd like to do is kind of go through all of these points, but have images along the way. So if you wouldn't mind going to the slide, and we can get started on this list here, because this is what we really like to focus on. So this here is color printed parts off the HP 580, as you can see. And the first thing you'll notice is the incredibly improved aesthetics of this part. And now the color actually pops, right? And the reason being is, remember in the beginning when I was saying we create this flow state on the surface? The part on the left, the raw part, when it's being fused, the colored parts are surrounded by white powder. And this is the same with SLS or anything like that. There's always this partially fused layer of powder, and that's what we're focusing on. And so once we liquefy that and start flowing that material, bringing our peaks down into our valleys, and kind of leveling out that surface, you'll then turn it into what you see on the right, very smooth and sealed surface, and bringing that partially fused powder into the surface. And that's how we now reveal the true color of that 580's color capability, and bringing you closer and closer to that color that you desire for, whether it's color coding or particular applications that need very color specific information on them.
This was probably the most eye-opening, literally, right, and dramatic effect that we've had with our customers when we show them the vapor smooth parts. I mean, we were the exact same way. We happen to have a customer of ours that has your technology, and I went to their facility and saw that, and I was absolutely blown away on how, you know, vivid the colors were that we were never able to get out of the HP 580 without going through this process. So I think this is just a huge eye opener, but it also creates a lot more uses for those parts, especially when it becomes, you know, one of the benefits of the HP printing technology or multi-jet fusion technology in general is the speed of it, right? And we're starting to see these parts, or customers wanting to use these parts in end use part conditions, right? Rather than just prototyping. But they weren't quite there with some of them, depending on the application and the needs, until we got them involved, or you got them involved with vapor smoothing. And then that opened up a whole new opportunity for them to get in front of the customers with. So that's, it's just amazing the difference here.
Yeah, absolutely. Yeah, I mean, and it brings it that brings it from that kind of prototyping look in that raw part now to this final production, marketable, actual usable production level part, similar or even better to injection molding, because now we can tie in the complexity of 3D printing, like this perfect part here. Great example. We have a question here about the ability to smooth filament parts, and yes, absolutely. You'll see later on here some images of some filament parts that we can also smooth. So, and we'll cover it in another slide, but this technology is agnostic. So it can handle many different printing platforms as long as the material that is being printed with is a type of thermoplastic. So we can't do things like SLA or DLP or metals right now. That's just the chemistries that we have designed, and the way the machine is built doesn't handle those type of technologies. But yeah, just to come back to these parts here, as I mentioned, we have a really controllable chemistry, and the tuning of the machine allows us to give us a really good finish and also prevent color bleeding or even dye from bleeding. So you can see here that the color doesn't run. We're not melting the inks off of the part, and that also goes along with any parts that you might dye. You know, SLS has the ability to change any kind of single color. And we get a common question of, do you have to dye your parts before or after vapor smoothing? It's up to you. It's up to your workflow, whatever works best. We suggest smoothing the part first and then dyeing. There's huge benefits to that. One, it gives you a very uniform finish on the outside. It reduces your dyeing time because we've actually reduced the surface area on the part, because we brought those peaks down into those valleys, giving you that nice finish. So now your dyeing times are faster, and you just get a much more uniform dye because that surface has been vapor smoothed properly.
Someone's asking here, does vapor smoothing improve strength significantly? Did you answer that question, or is that?
No, we have not, and maybe I can talk a little bit about that. You know, the improvement on mechanical properties, it's really significant, and the best way to explain it is that we're talking about 3D printed parts, made layer by layer. So at the end, you end up with a surface that is made up of layers. There is stair stepping in some instances. There is porosity that comes from the process, and also from the settings that you use, from the orientation of the part. So sometimes, you know, a part breaks not necessarily because the material properties are poor, but because you have all these imperfections at the surface. And that's what our process does. Like, it really focuses on healing the surface of the part in a very automated and in a very controlled way, so that we can get rid of all those crack initiation sites, all those micropores that, you know, although they may not look significant when you're handling these parts, when you inspect them under a microscope, you can understand how and why these parts break. So by being able to seal them and by being able to erase all those imperfections, what we are doing essentially is improving any of the properties that will be dependent on a micro crack initiation at the surface. For example, elongation at break. The elongation at break, depending on the material, if it's nylon 12, you should expect out of our process an improvement of about 25 to 30%. If it's nylon 11, you're going to see improvements of about 100 to 150%. And you may say, wow, 150%, you're stretching. Think of a dog bone, for example, a tensile bar. Stretching a nylon 11 part that much, you may say, you must be softening the material. And that's one of the uniqueness of the chemistry that we use, is that it does not damage or changes the mechanical properties of the material itself. So no, we're not softening the material. We are retaining the modulus, the tensile modulus of it, so the stiffness of it. But we are healing the surface, and in doing so, we're gaining the mechanical properties. Impact resistance is another one, for example. So, the harder it is for that initial impact to break through the initial surface, the better the performance. So the on-the-field performance, whether it is a part that is under tension, compression, or bending, you will see that you have much better high cycle fatigue resistance. And as Brad said, a sealed surface will also give you just better abrasion resistance. The parts will not scuff or get marks or get, pick up any type of impurities as easily. So that's essentially how we're seeing the benefits on the performance. But as you can appreciate now, our process started on the aesthetics, but when we truly, through engineering and chemistry, discovered that we can control it so that, we can, with this fast-acting chemistry, it really unlocks a very powerful tool, because now you can introduce, you can treat a part in a way that no other dipping or clear coat or any other type of application would treat it. The vapors are controlled in a way that there is no line of sight issues. They can go through very small orifices, very complex geometries like lattice structures, for example, and we can treat and we can get, it's the only process that will guarantee a surface finish without a pickup in weight, without changing the dimensional properties of your parts, and without changing the without changing the colors, and without changing necessarily the design performance elements of some of these printed parts. So yes, that's hopefully that answers that question. And we have other examples. We have a lot of data depending on the material. If some of you are interested in a specific material, we have HP nylon 12, nylon 11. We can treat Ultim, for example. So we have a lot of data, actual mechanical data, not for all the 120 plus materials that we treated, but we also welcome any questions, and we can provide that data. So
maybe move on and show some of those other images that we have, because some people definitely want to see some of the onyx material as well. So I think this one's again, pretty impactful, right? I mean, the same part that we saw earlier, but again, as we spin it around here, you can just see a significant changes in the texture and the vividness of the color as well. So I'll pass it back to you, Brad.
Yeah, thank you. And just one good thing to point out is the part on the right there has a lot of intricate detail, parts coming to sharp points. There's fine lines of color and all of that. And you can see that we still have the ability to control a great finish. The product on the right is that smooth sealed finish. This is actually a tap handle, and the benefit of vapor smoothing that surface is now that it's completely sealed, that can prevent bacterial growth. That surface can now be cleaned and sterilized. At the end of the day, I'm sure the bartenders are wiping those things down with all sorts of stuff, and being able to keep that material intact and cleanable, it's good for the next day. And just to touch on the resistance, scratch resistance that Luis was mentioning, happy hour can get a little crazy, right? So there's a lot of movement on parts like that, so increasing its durability and everything is really a good focus of the technology. But because of that, it allows us to go into environments that involve liquids, oils, gases, because this surface is now air and water tight. We've had many different applications that actually hold under pressure, things like manifolds and piping and pumps and things like that, and actually able to move liquids through the part under pressure without any kind of leak, which is fantastic. Now it's unlocking many different applications. And one good thing is the medical environment. Because this is sealed and prevents bacterial growth, we can clean and sterilize that and be able to use it in different environments, especially with what's going on now and the spike of it last year with COVID and everything. So many different applications are coming out. So we're able to utilize vapor smoothing to, instead of these parts becoming one-time use, they can now be reusable. And then we can go ahead through some of these slides here. just to get some eyes on filament parts. And Luis, that you started talking more about properties, but if you want to dive any deeper on some other topics here.
Yeah, I think when it comes to the filament, technologies, you can see that a lot of times, even if it's the same material, printed in the same, model of printer by two different companies, you're going to get drastically different densities and different quality of the prints. What our technology is doing is essentially it can normalize some of those differences by sealing these parts and getting rid of all the porosity on the surface, boosting the density of your part, and making a part that before was looking like a prototype now looks like a finished part, but it also has better properties that are coming just for the fact that you had treated the part. So it's and we're doing it just to touch on the chemistry. It's a safe chemistry. It's medical grade alcohol that will not damage the parts. I think the worst thing you're going to find out about it is that it's an upper respiratory irritant, but that's where all the controls on the technology being a closed loop system, where the user or the operator never comes into contact with it. The parts at the end are guaranteed free of chemical. So it is a chemistry that is being used in pharma to produce a lot of anesthetics. So it's something that is not flammable, is none of the nasty chemistries out there. So I just want to point that out because many of you have, when you hear chemical vapor smoothing, may have the concept, the perception that, it must be some harsh, nasty chemical. It can be further than the truth. That is the key component of our offering. So when it comes to the filament parts, it really does a phenomenal job at changing all those end of vector layering effects, and just at times just getting a mirror injection molded image, show the onyx material. And like Brad said, when the material has any type of reinforcements, whether it's carbon fiber, we're only treating like about a 50 to 100 micron outer layer in a very controlled way. So as soon as the chemistry touches those end of vector or the entire surface, it's going to start dissolving, and we start pulling and extracting. As soon as that happens, we start reclaiming the vapors, turning them back into liquid, and recycling them in a different container. But at the end of the process, by doing that extraction, we can guarantee that everything is coming out of the part, and your parts coming out of the machine do not have to be rinsed and do not have to be treated in any other manner before they go into the end use.
So we have a wide range of users here attending, so thank you again. So I just wanted to use this slide to share, the not so limited use of vapor smoothing. And so again, like I mentioned, this process is technology agnostic. It can process the majority, if not all, thermoplastic materials. And so based on printing technologies, we can handle parts from things like selective laser sintering, like EOS and 3D Systems machines. Of course, HP multi-jet fusion, high-speed sintering from things like Voxeljet or ZAR, and then also with extrusion, so filament fabrication, like things from Juggerbot and Ultimaker, fused granular fabrication from DSM, or even high-speed extrusion from people like Ascentium. So it really doesn't matter the platform, but it really comes down to the material. And as you can see further down, we can process things from rigid plastics to elastomers and composites. There was a question in here, we don't have the material listed, but do we have plans for PETG? Yes, we can still vapor smooth that very, very well, especially if we get some clear. It looks really, really good. So we're able to smooth that as well.
I should point out, Brian, I'm sorry, really quick. This technology, what we found out also is that it's not just limited for 3D printed parts. It can also treat parts that are coming from injection molding. It really has been a phenomenal solution to erase any imperfections, surface imperfections coming out of parts that have to be machined or milled via CNC, or that are injection molded and need to be clear and optically transparent. Removing some of the haze from it, removing some of the scuffs that come from the parting lines, and from removal of ejection pins and the runners from injection molding. So just something to point that out.
The one thing that I do want to mention is this is our very first webinar with AMT, and we're going to be doing a whole lot more in-depth informational webinars coming up. Our application engineers are going to get more involved. This was really geared towards kind of kicking off our relationship and exposing various to our customers this technology that they weren't familiar with. So if you didn't get everything you were hoping to get out of today's webinar, which there's obviously a lot to talk about, please feel free to touch base with Hawkridge, and we will work with you directly to get your questions answered and so on. So Brad and Luis, I'll pass it back to you real quick. I just wanted to mention that.
Like Brad said, the technology we as a company started with the vapor smoothing technology. What we find out is one of the single biggest variables comes from the process upstream, which is the cleaning and the depowdering or the support removal of the part. And that's why we wanted to introduce a technology that can get rid of that variability and do it consistently and repeatably and affordably. So we dive into the depowdering technologies, which are all about reducing time, labor, and ensuring. I also remember my days cleaning some of these parts, and remember that they did not used to be as consistent as on my bad days. So this gets rid of the user operator variability and gets it ready for Post-Pro 3D. The two combined, it's really a powerful tool for anybody trying to reduce costs and gain value. Yes, I agree. We should have more in-depth applications.
Here's our contact information. Please get in touch with us if you have any additional questions. We would be happy to engage in a conversation with you a little bit more about your specific applications or answer your questions. And then the other thing is, for those of you that are maybe a little more past just the discovery phase and you want to really kind of dig deeper into your specific application, we also do benchmarks, right? So we'll take your parts, we'll take a look at that, we'll have a conversation with you about your parts, create some benchmark for you, and then get those parts back to you for you to evaluate. So with that being said, Brad, Luis, thank you so much for helping us out here today and giving our audience a little bit of an overview of AMT technologies. And for all of you that attended, thank you, and stay tuned for, via our newsletters and social media and everything else about additional webinars coming out on AMT. So thank you, everyone. Take care.